Welcome Math 1111ers. This is the lecture for section 2.2, which covers quadratic functions. We'll look at two different forms that you can write a quadratic function in, sort of along the idea of writing the equation of a line in slope-intercept form or writing it in point-slope form or standard form. So it's the same equation. It can just be written in different forms. Well, we have the same thing with quadratic functions and quadratic equations, and we'll be talking about two different forms we can write and then graph our quadratic functions in. So I'm going to go ahead and get started here. All right, so the first form that we come to is, in this textbook, is called standard form of a quadratic function. And most textbooks that I've taught out of actually call it vertex form, so that's why I put that in parentheses, because I know that, my bamboo tablet's about to die. Let me get that plugged up. I know that a lot of you will go out to YouTube, or you have other sites, other people that you work with on your math, and so I just wanted to let you know that this form is also commonly referred to as the vertex form of a parabola. I'm going to stop this hooked up here. Sorry. There we go. Let me get it out of my way. Cord. Okay. All right, so let me just talk a little bit about the parabola itself and point out some important features of the parabola. The first thing that I would like to point out is the vertex of the parabola. So that's this point when the parabola is opening downward. Sorry, there we go, downward. It would be the highest point of the parabola, and if the parabola is opening upward, then of course it would be the lowest point on the parabola. So it's the vertex of the parabola. In this case, it's the highest point. It's defined as where the function switches from increasing to decreasing or vice versa. So we have the vertex of the parabola. We also have this very important vertical line here. So as you can see, when I draw a vertical line through the vertex of a parabola, that it splits the parabola into two symmetrical pieces. This imaginary line, I guess, that we can draw to split the parabola that way is called the axis of symmetry. It will always be a vertical line because the parabola will always be oriented either opening up or down. It doesn't open to the side. So since it's always a vertical line going through the vertex, the equation of the axis of symmetry is always x equals whatever the x-coordinate of the vertex is. I'm just going to put x-coordinate of the vertex. So let's just think about that. Let's say that this, and actually this vertex actually is 3, 5. So the equation of this axis of symmetry is x equals 3, because it always goes through the vertex. Because parabolas are always symmetrical. So In other words, I'll always be able to draw a horizontal line and have a point come out on the graph at the same vertical value or the same y value, and those 2 points will also lie equidistant from the vertex itself. So I'm marking this thing all up here. I'm trying to think if there are other, let me write that word at vertex. That's that special point there. And I don't think at this point there are any other major characteristics that we need to talk about before we go ahead and jump into what is standard form, i.e. vertex form, or AKA vertex form. Let me get all this off of here. Okay, so the standard form of a parabola is f of x or y equals a times x minus h squared plus k. And this probably looks really familiar since we've already started talking about transformations. So I'll just point out a couple things about this particular form. The point HK is the vertex. That's why most texts call it vertex form, because your vertex shows up in the equation of the parabola. So in this case, notice minus is in the form. So if you have a plus on the inside, you need to rewrite it as minus a negative. Let me just write an example down of that. So say this equation had been negative x plus 3 squared plus 5. Minus is in the form on the inside of the function. So I would want to rewrite that as x minus negative 3 squared plus 5. That would mean that the x coordinate of the vertex is negative 3, not positive 3. But in this case, it's positive 3. So the vertex shows up here as 3, 5. So 3, 5 is our vertex. And you can see, looking at a graph of this, sure enough, 3, 5, our vertex lives at the point 3, 5. This A right here is the same A that we talked about with transformations. So it is going to govern the positioning, whether it's positioned in the same position as the parent function, x squared, or it's reflected over the x-axis if the A value is negative. So the sign of A, if it's positive, it is positioned opening up, and if it's negative, it's positioned opening downward, like that. So that's the sign of A, and then the value of A, if A, or the absolute value of A, is greater than 1, then we have a vertical stretch. If the absolute value of A lies between 0 and 1, then we have a vertical compress. Okay, or shrink is what your textbook calls it. So that's vertex form in a nutshell. We'll go ahead and move to the next slide and work with this form a little bit. So just for reference sake, we have y equals a times x minus h squared plus k. And let's talk about how we can use that form to graph the parabola. First thing you want to do is determine, does the parabola open upward or downward? So we have our function here, and we can see that a is negative, so our particular parabola opens downward. But in general, how we figure that out is we look at the sign of A. So once again, positive A opens up, negative A opens downward. So let me actually make our particular parabola's information a different color. Okay, let's try orange. So our particular one is opening downward since A is negative, and that's right here, down at the bottom there. Okay, determine the vertex of the parabola. Well, in this particular form, the vertex of the parabola is given by HK. So the vertex with this particular parabola is 3, 5. Now notice it says minus in the center, so just sitting in the position of H is a 3. If it said plus, I need to change it to minus and negative. The X-Intercepts. How do I find the X-Intercepts? Well, it's the same no matter what kind of equation you're trying to find the X-Intercepts for. Whenever you're looking for X-Intercepts, you always plug in 0 for y and solve for x. So solve for x. All right, so in this particular equation, I'm going to do the work over here so that I have room. So my function is f of x equals negative x minus 3 squared plus 5. And I plug in 0 for y, or f of x. So that's 0 equals negative x minus 3 times x minus 3. Actually, I'm going to do it a different way, I think. Yeah, I'll do it a different way. I'll use the square root property instead. So I have negative x minus 3 squared plus 5. I would then subtract 5 off of both sides. And that gives me negative 5 equals negative x minus 3 squared. I want to divide that negative off because I want to isolate the squared unit before I take the square root of both sides. And that leaves me with 5 equals x minus 3 squared. Now I can take the square root of both sides. And I get positive and negative square root of 5 equal x minus 3. Add 3 to both sides. And I get that the X-Intercepts are x equals 3 plus or minus the square root of 5. And if I go to my calculator, let me see if I've got my Collaborate fixed so I can take y'all and share my desktop. Doesn't look like it's going to do it again. I'll go to a URL. Let me get the URL for the calculator. All right, we'll see if this works. And go. Okay, free online graphing calculator. I don't know if y'all can see that or not. Web tour side trip graphing calculator. Hopefully it's showing up for you. Oh, actually, I guess I don't need a graphing calculator. I just need a regular calculator. I don't know if this will just do calculations. Graph. Yeah, it's set on y equals. Let's see if we just can find a free online calculator. Let's see. I'm sorry. Let's see, online scientific calculator. Let's try. Search. All right, so I'll just do the math myself on my calculator on my desktop that I can't show y'all. I promise I'll get this figured out why it won't let me share my desktop anymore. Okay, so if I put 3 plus the square root of 5 into my calculator, 3 plus the square root, okay, so square root of 5, that's not working either. Goodness, I'm just having lots of trouble today. 5 square root, there we go, plus 3. Okay, so I get 5.24, about 5.24, and that's just for one of the X-Intercepts. But notice this point right here on the picture. There's the X-Intercept, and it looks like it's about 5 1/4. So that one is correct. And now we have to subtract the square root of 5. So 3 minus 5 square root equals 0.76. And if you look here, that looks like it's about 3/4 of the way to 1 on the number line. So those are our X-intercepts, and to find those, all you have to do is plug in 0 for y, or f of x. And there are a number of ways you can solve that. If it's factorable, you could factor and use the zero product property. I use the square root property here. You could also multiply that x minus 3 squared out and get it into the form of ax squared plus bx plus c equals 0, and use your quadratic formula. Your quadratic formula always works. So just a reminder about quadratics themselves. All right, finding the y-intercept. The y-intercept is actually much easier to find than the x-intercept. You're going to do just the opposite and plug in 0 for x. So basically you're going to be doing f of 0, because that's what that says. Plug in 0 wherever you see x into the function. So negative 0 minus 3 squared plus 5, negative 3 squared, plus 5, Negative 3 squared is 9, but there's a negative out front, so that's negative 9 plus 5. And you get negative 4. And just to point out, once again, this is a y-intercept that we just found. And if you look at the y-axis right here, it's where the function crosses the graph. So we have the point 35 is the vertex. No matter what form your equation is, how you're graphing it, you always, always, always have to graph the vertex. You can't just kind of fudge it at the top. You have to figure out what the actual real vertex is, and that has to be part of your graph of your parabola. 3 points determine a parabola, and so we usually just use the x-intercepts and the y-intercept to sort of give us a guideline to graphing the remainder of the parabola. So once you have your points graphed, you just draw a smooth curve through it, like so. All kind of smooth. And I didn't even hit my last mark there. And arrowheads on the end, it does go into infinity either way. All right. So that is the vertex form of the parabola. Your book calls it standard form. And the next form is good old quadratic. This is what I've always referred to as standard form. X squared plus bx plus c. So you can see I have a function in this form, and the a in this particular form is the same a that you're used to dealing with. So the sign of a tells how it opens. So in this case, a is negative 1, so this thing opens down. And that's it. Nothing different from the other one. I'll talk about the other parts of it on the next page. But I will point out, if you notice, this is the same graph we were just looking at. Look, the vertex is the point 35. We have x-intercepts of approximately 0.76 and approximately 5.24, and I have a y-intercept of negative 4. Why I showed you this in this form is that, let me get a bolder pen here. It's because this is the same exact function as y equals negative x minus 3 squared plus 5. All I've done is multiplied it out and gotten it into ax squared plus bx plus c form. So I just wanted to show you, and I'll actually multiply that out. I think that would be helpful for some of you to see. I can grab it all. Okay, let me move it up. And I'm going to do the actual math for you. So, to multiply this out, I do x minus 3 times x minus 3 plus 5. I have distribution here. And this is what I end up with. Negative x squared minus 3x minus 3x plus 9 plus 5. That's negative x squared minus 6x plus 9 plus 5. The negative, understood negative 1, now gets distributed to the terms inside the parentheses. So we have negative x squared plus 6x minus 9 plus 5, which leaves us with negative x squared plus 6x minus 4. Same exact thing right there. So I did this just to point out the fact that you can have an equation that looks very different, but it's the same exact equation, so of course it's going to graph the same way. Different steps when it's in this form, but the same idea. You want to get your vertex, you want to get your x-intercepts, your y-intercepts, and draw your smooth curve. So let's look at how we get those characteristics to graph. Okay, so the first thing you want to do is determine if it opens up or down. Well, A, in this case, here's our function. A is negative, so in our case, it opens down. In general, just like with the last form we were looking at, positive A opens up, negative A opens downwards. And they call that concave up and concave down, but opens up, opens down, that's fine with me. Okay, determine the vertex of the parabola. Well, you don't have it just sitting there for you. And I'm not going to go into detail as to where this came from, but it's part of the quadratic formula. The vertex of the parabola in this form, the x-coordinate is negative b over 2a, and the y-coordinate, of course, is whatever you get when you plug in negative b over 2a into the function. So that's the x and the y coordinates of your vertex. So in this particular case, my A is negative 1, and my B is 6. So the x-coordinate, of my vertex is negative b over 2a, so negative 1, negative b, my bad. Ugh. I almost blamed it on a Monday, but I can't even blame it on that because it's Tuesday. It's been one of those days, though. Negative 6 over 2 times negative 1. Which, don't forget, we found out in the last form that the vertex is going to be 3, 5, and you can see it in the picture there. So this is the x-coordinate. Negative 6 divided by negative 2 is positive 3. Then my y-coordinate of my vertex is what I get when I plug in that positive 3 into the function. So negative 3 squared plus 6 times 3. I need to make my pen a little smaller again. Minus 4. Okay. So this is negative 9 plus 18 minus 4, which is 9 minus 4, or 5. So now I have that my vertex is the point 3, 5. You're going to find the x-intercepts and the y-intercepts the same way. So in general, for an x-intercept, plug in 0 for y. Okay. I'll do this one with the quadratic formula so that you can see what it would look like that way. So I have 0 equals negative x squared plus 6x minus 4. A is negative 1, B is 6, C is negative 4. X equals opposite of B plus or minus the square root of B squared minus 4AC. I'll write that at the top. The quadratic formula. X equals opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So opposite of 6 plus or minus the square root of 6 squared minus 4 times negative 1 times negative 4 all over 2 times negative 1. X equals negative 6 plus or minus the square root of 36 minus 16 over negative 2. X equals negative 6 plus or minus the square root of 20 over negative 2. I'm going to have to clear off some room here to finish the set. I'll clear off on top of the graph here. Okay, so finishing this off, I'll come up over here. X equals negative 6 plus or minus the square root of 4 times the square root of 5 over negative 2. X equals negative 6 plus or minus 2 square root 5 over negative 2. I can take a factor of 2 out of each of these and I get, actually I can take a factor of negative 2 out of each of these and I get 3 plus or minus the square root of 5, which we already know, we've done the math, that's 0.76 as well as 5.24. So there are our X-intercepts. Y-intercept in general, you always plug in 0 for X. And doing that is quite simple. F of 0 equals negative 0 squared plus 6 times 0, 0, minus 4, which just gives us negative 4, which we already knew. It's sitting right there on the graph. So you're going to find the same thing. The only difference with these two methods is how you get the vertex. And in this particular one, in this particular method, you get the vertex by doing negative b over 2a and f of negative b over 2a. Other than that, the process is the exact same. Okay, so we have a couple of practice problems here. This first one is in vertex form. And I'll just remind you that f of x equals a times x minus h squared plus k. The first thing we want to do is determine if this opens up or down. And a is understood to be positive 1. So up or down. A equals positive 1, so this thing opens upwards. The next thing is the vertex. Notice this one's got plus in the formula, or I'm sorry, in the equation. So I need to rewrite this as f of x equals x minus negative 4 minus 10, which means our vertex hk is negative 4, negative 10. The X-intercepts are what I get when I plug in 0 for y, so 0 equals x, oh I'm sorry, this thing is supposed to be squared. I have a typo here, that should be squared. Sorry about that. So x plus 4 squared minus 10. Add 10 to both sides. 10 equals x plus 4 squared. I'm ready to take the square root of both sides. The square root of 10 is the square root of 10. And I'm left over here with x plus 4, so I need to subtract 4 off of both sides. Oh, I'm sorry. I get positive and negative square root of 10 when I solve the equation. Sorry about that. So negative 4 plus or minus the square root of 10 equals x. And I'm just going to check my calculator to get an estimation of those two intercepts. Okay, so see, negative, negative 4 plus square root of 10 is approximately, let's see, so x is approximately, I lost my calculator, there it is, negative 0.8, so not quite negative 1. And when I subtract, I get, okay, so negative 4 minus the square root of 10, negative 7.16. And the only thing I have left to find are the y-intercept, is the y-intercept. You'll never have more than one y-intercept, or it would not be a function. So I plug in 0 for x, so f of 0 equals x, 0 plus 4 squared minus 10, which is 16 minus 10, or 6. So now I'm just going to go and plot all 4 of these points that I have found and graph my parabola. My vertex is negative 4, negative 10. 1, 2, 3, 4, and down 10 puts me about right here. I have X-Intercepts of negative 7.6, or I'm sorry, 7.16, so 7 and some change. So negative 5, 6, 7, and just a little bit, so maybe about right here. And just be as close as possible with that. And then negative 0.8 is almost negative 1. And you can see I'm already starting to shape so that it's opening up, which we found out very first thing. The last thing I have is my y-intercept, and my y-intercept is 6. Here's my parabola. And it's a curve, not a V. So it's a U shape, not a V shape. A hard V is the absolute value function, so we want to make sure that we don't put a hard corner on our parabolas. All right, that's it for vertex form. Then we've got what I've always called standard form. And just to remind you, the vertex, when it's in this form, is given by negative b over 2a and f of negative b over 2a. Okay? All right, so first off, is it opening up or down? Well, a is understood to be negative 1, which means this thing's going to open downward since it's negative. The next thing we find is the vertex. So for the x-coordinate, negative b over 2a is negative 2 over 2 times negative 1, because here a is negative 1, b is 2, c is 3. So negative 2 over 2 times negative 1 is negative 2 over negative 2, which is just 1. And then, by the way, this is the x-coordinate. And then to find the y-coordinate, I just plug it in to the function f of 1. So negative 1 squared plus 2 times 1 plus 3. 1 squared is 1, but it's negative. So negative 1 plus 2 plus 3 is 4. So I find out that my vertex is 1, 4, which I could go ahead and graph if I wanted to. It's right here. The x-intercepts are what you get when you plug in 0 for y, so, or f of x, so 0 equals negative x squared plus 2x plus 3. I'm going to use the quadratic formula. I could factor it and use the zero product property if I want to, but the quadratic formula always works. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So negative 2 plus or minus 4 plus 12 over negative 2, which is negative 2 plus or minus the square root of 16 over negative 2. I'll come up over here to finish. Negative 2 plus or minus 4 over negative 2. And so we have two different ones. We have a plus and a minus. Negative 2 plus 4 over negative 2 is 2 over negative 2, which is negative 1. So I have an x-intercept of negative 1. And then I also have negative 2 minus 4 over negative 2, which is negative 6 divided by 2. I'm sorry, but divided by negative 2, which is positive 3. So you can see they lie equidistant from the vertex. So I'm good, since they have the same y values, and they have to because they're both x-intercepts. All right, moving forward, the last thing we do is to find our y-intercept. And that is found by plugging in 0 for x, so f of 0 equals negative 0 squared plus 2 times 0 plus 3. So I just have 3. 1, 2, 3, right there. And I'm ready to graph my parabola. That's it. I have a couple more slides with one more big concept to talk about before this video is done. Okay, so maximum and minimum values. It should make quite a bit of sense that a maximum value in a parabola or a minimum value is going to be the vertex. It's the highest and the lowest point. So if your parabola is opening up, then you're going to have a minimum. If it's opening, can't do that with that hand. If it's opening downwards, you're going to have a maximum. You're going to have a high point. So that's what this first part of the notes is talking about. Consider the quadratic function f of x equals ax squared plus bx plus c. If a is greater than 0, then the parabola opens upwards, and the vertex is the minimum. If a is less than 0, the parabola opens downwards, and the vertex is the maximum. So just to give you a visual, opening upwards, you have a minimum. Opening downwards, you have a maximum. Okay, so you're going to encounter let me finish reading what it says here. The x-coordinate of the vertex is negative b over 2a. We already know that. Thus, we can find the minimum or maximum values by evaluating the quadratic function at, so plugging in, doing f of negative b over 2a. So finding that y value, that maximum and that minimum value. So what this means here, evaluating the quadratic function there, that means doing f of negative b over 2a. So you're going to see word problems that say maximize this area or maximize profits, minimize something. Whenever you see those words, all you have to think is, I'm focusing on the vertex of this parabola, even if there's no picture of it for you to look at. So you're going to read the problem, decide what needs to be maximized or minimized, use the problem to express it in one variable, rewrite it in function form, and then you're going to do negative b over 2a, f of negative b over 2a, and then answer the question. So let's take a look. An archer's arrow follows a parabolic path. So I'll just give you a visual, and I am a terrible artist, so get ready to laugh. So we have green grass here, and my archer, we'll draw him in black. And we have our archer here, and he has a bow. This is going to be terrible, with an arrow. And what this is talking about is it follows a path. When he releases it, it's parabolic. And it can be modeled by this function here, where x is the arrow's horizontal distance in feet. So horizontal distance in feet. What is the maximum height of the arrow, and how far from the release does this occur? So the maximum height of the arrow is going to be talking about the y value. So this is going to be height. And the maximum height will be the y value of the vertex. So the height is going to be the y value. How far from release is going to be the x value of the vertex. So we're looking for those values. I just do negative b over 2a and f of negative b over 2a. So the x equals negative b over 2a, and in this case, that is negative 2 over 2 times negative 0.005, and I'm going to put that into my handy-dandy calculator. So 2 divided by 2 times negative 0.005. And I get roughly, no, that didn't come out right. Let me do this a different way. 2 times 0.005 is 0.01, so negative 0.01. 2 divided by 200. I'm going to get my hand calculator and check this. I don't like using these calculators on the desktop. I never feel like I can get them to do what I want them to do. Okay, so 2 divided by 2 times 0.005. Okay, so I get negative 200. Oh, it should be positive 200. I don't know why I put a negative sign. Negative B should be positive. I apologize. So right here inside that should be a positive 2. So that comes out to be positive 200. That makes sense. So I get positive 200 for my x value. And for my y value, I have to do f of 200. So that's negative 0.005 times 200 squared plus 2 times 200 plus 5. Let's see what we get. Okay, so negative 0.005 times 200 squared 200 squared times negative 0.005. Okay, so this part right here is negative 200, and then I'm going to add 400 plus 5. So we get 205. 205. So to interpret, the max height is 205 feet, which occurs 200 feet after release. Find the horizontal distance the arrow travels before it hits the ground. So that's when the height, or the f of x, the y, is 0. So I just plug in 0 for y to figure out when that happens. 0, 0, 5x squared plus 2x plus 5. I'm going to stick this into the quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that equals negative 2 plus or minus the square root of, I'm just going to do this, 4 times 0.005 times 5 is 0.01, so 4 plus 0.1, so 4 plus 0.1 is just 4.1. Square root of 4.1 over 2 times 0.005, which is negative 0.01. Hang on. 4 times 0.005. 0.1. Okay, yeah, I'm just double checking. The square root of 4.1. Okay, so we have, up over here, negative 2 plus or minus. The square root of 4.1 is approximately 2.02 over negative 0.01. So we have a plus and a minus. So negative 2 plus 2.02 over negative 0.01, and negative 2 minus 2.02 over negative 0.01. So we're trying to find out how far it had to travel before it hit the ground, before it came back down. Okay, so here we have 0.02 divided by negative 0.01. And that's going to give me negative, that's going to give me negative 2. So what you have to know, so here I get negative 2. There is no such thing as negative distance, so you don't even have to consider that one. And then the next one, so that's negative 4, so 4.02 divided by 0.01. This gives us 402. And that makes sense. If it's at its highest peak at about 200 feet, then it's going to come down and hit the ground at 402. So there you go. that's maximizing and minimizing. You'll have some other problems to deal with that in your homework. Just as a quick reminder, Unit 4 stuff, 2.1, 2.2, and 2.3, homework and quiz are due Monday, March 17th. So not this coming Monday, but the next Monday after that. You still have some time. It'll be open on the 13th, which is not this coming Thursday, but next Thursday. The next lecture is this coming Monday, the 10th at 3 o'clock, and I'll cover section 2.3. Hope to see you there. Y'all have a good day.